When we talk about zeros of polynomials, it can be useful to understand that if we have a complex zero, of course complex numbers include the real numbers, but what I mean by complex here is has the number I, the imaginary number I. So complex zeros and irrational zeros, so to make this very clear, has a square root. So like square root of 3, square root of 5, square root of 6, square root of 7, any square root that doesn't simplify is what we'll call irrational for this video. So if you have a complex zero, then you're guaranteed that there is another complex zero. If you have an irrational zero, then you're guaranteed that there is another irrational zero. Now, this is all true when you're dealing with polynomials that have rational coefficients, okay? So we're not talking about polynomials that have complex numbers or irrational numbers. So the polynomial itself does not have these numbers, but the zeros could be complex or irrational. If that's true, then you're guaranteed to have at least one other. So let's see how this is true. If you think about the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so the quadratic formula typically results in two numbers because of this plus or minus, okay? Now I say typically because sometimes the part after this plus or minus is 0, and then you're not really adding or subtracting anything. But if there's a number here, you could end up with a square root. You could end up with an I if you get a negative under the square root. And so it's because of this plus or minus that gives us two zeros typically, okay? So let's look at some examples. So if we use the quadratic formula and we find that let's say the number 1, the complex number 1 plus 2i is a zero of a polynomial, then you can imagine where that comes from. That comes from this formula, and the plus here comes from the plus part of the formula, which means that if that's true, then the formula would also tell us that 1 minus 2i is also a zero. And so that's precisely what this video is all about. These complex zeros come in pairs. If you have one, you have another. And irrational zeros also come in pairs. So let's look at another example. What if we find that let's say 3 minus the square root of 6 is a zero of a polynomial, then the minus in this number comes from the minus part of the formula, which means we're missing the zero that has a plus there. So the formula should also tell us then that 3 plus the square root of 6 is also a zero, okay? And so what's happening here is these numbers have a relationship with one another. So that relationship is called conjugate relationship. So 1 plus 2i and 1 minus 2i are called conjugates. And 3 minus the square root of 6 and 3 plus the square root of 6, those are also called conjugates, okay? What makes them conjugates is, well, in this case, they're the same with a plus or minus in front of the imaginary part. So in this case, the imaginary part is the 2i part. So one of those has a plus in front of the 2i, and one of them has a minus in front of the 2i. Conjugates in this case, with the irrational case, is they're still the same, but with a plus or minus in front of the irrational part. In that case, that's the square root of 6. So one has a negative in front of the square root of 6, one has a positive in front of the square root of 6. So our conclusion from this video, the most important statement from this video is if a complex number or now when I say a complex number, I mean a complex number that has I. So if a complex number or an irrational number is a zero of a polynomial with rational coefficients, then its conjugate must also be a zero. Okay? So this is important. Sometimes, now there are lots of applications of this. Sometimes when you're solving a problem, they won't give you all the zeros. And it's up to you to know that there are other zeros that aren't listed. So if some zeros are given, it's up to you to know that the conjugates must also be zeros, and that can help you solve different sorts of problems. Okay, so let me emphasize these two statements very quickly. I'll put them inside this box here, and let's look at a question that this could help us maybe solve. If we have a degree 5 polynomial with zeros let's say 1/2 square root of 3 and 2 minus I times the square root of 5. Okay? If we have a degree 5 polynomial with these zeros, then what are the other zeros? Now, a degree 5 polynomial, you would expect to typically have 5 zeros. And it doesn't mention anything about multiplicity here, so we'll assume these are each a 0 one time, which means we're missing 2 zeros. And so we see that we have an irrational 0 here. This is the same thing as positive square root of 3. So the conjugate of that must also be a 0, which means negative square root of 3 is also a 0. Okay? And 2 minus I square root of 5 has a negative in front of the imaginary part, so its conjugate 2 plus I square root of 5 is also a 0. So those are a couple cases. Here's an irrational. Now notice this doesn't have a number in front of the square root of 3, it's just square root of 3. That's still irrational, so its conjugate would be negative square root of 3. And the same is true if you just had an imaginary number without this part, then you would still have a plus or a minus in front of the imaginary part here to get two different zeros. Okay, but I just want to give you a quick example of what this could help you with. Now you could do a lot of different things with this information. I'm not going to go into that because I don't know what types of problems you're trying to solve. This could help you with graphing, it could help you with factoring a polynomial because zeros give you factors, etc., etc. But I just want to give you one example where this concept is applied. Okay, so complex and irrational zeros come in pairs.